Hello friends, this is Steven. Today I want to work on paint the fence. It's a problem that I struggled with in actually trying to look at it in depth and be able to drive the equation. So my goal is to be able to help drive the equation and show you kind of the steps of thinking through driving that equation so that you too, if you could get something similar to this and not the same, so you don't have to memorize equations and you can kind of look at it and see the logic behind it. So that's the goal. So what we'll do here is, let's start out. So we have a picket fence here. And today we have pink, a bucket of pink, we have a bucket of purple, and we have a bucket of green. So though we're going to choose here, so the number of colors we have, right? So we have 3 colors available for us. This can always change, right? We could have 2 colors, we could have 1 color, we could have 15 colors. But I think from this we can derive the core base equation. So let's start with just one picket. So we're here Saturday morning, we have nothing better to do and we want to color this picket. So we have these 3 paints. Let's derive how many different ways that we can paint it, right? With one picket, I could paint it pink, or I could paint it purple, or I could paint it green. So I have the option here to paint it whatever colors are in my bucket. So here, my equation, the number of colors that I can paint here, right? So the number then would equal colors. So in this case, for one picket, we would be able to paint that picket in 3 different ways. And so that would be our starting point for this. All right, so the next thing that we want to do is we want to think about, we started with one picket, and so I rewrote it up here and I said, so the ways to paint when we're just considering one picket, the equation for that is just equal to the number of colors that we have available to us. So when we have that, we have 3 colors, so the ways to paint on one picket, the answer would be 3. If we had 4 colors, the answer would be 4. Now the next part that we want to think about is, now when we shift to 2 pickets, how do we figure that out? So we really have 2 different buckets. So we have this same bucket and we have a different bucket. So in this paint the fence, one of our requirements is that we can only paint 2 pickets in a row the same color. So that's going to be one of the core basics or the foundations of our equations. So here, for the same, right, for 2 pickets to be the same, it's similar to the same equation that we had for ways to paint one picket fence, right? So in this case, one way that I could start out for these 2 is I could paint them both pink, so one way, or I could paint them green, or I can paint them purple. So the same that I have, or the number of permutations that I would have for that, in this case would be the number of colors. So then we come here, one thing that we could consider is that these could be painted the same color, and in this, for that part of the equation, same would be equal to the number of colors. So then the next step would be okay, if we have the same taken care of, another part in that equation is we know that we can paint the second one a different color. So let's think about that. Is if I painted the first one color, so I don't know, here we'll start with purple. So I start here with purple, and then I'm thinking about what can I paint the second picket, right? And so in this equation, what I can paint that second picket would be the number of colors that I have minus 1, because I've painted this one, and we've already accounted up here for purple and purple, so we have to subtract that out. So I have 2 different options. Purple can either go to this color picket or that, right? So I started with 3 colors, so 3 minus 1 gives me 2, and these 2 pickets represent that. And so either it can be, in this case, I could paint the next picket green, or I could paint the next picket pink. So in another way to think about this is that I have my first picket, right? And so I figured out what my first picket is, and then my other options here, right, in this case, is like times 2, times the color. And we can work through the same thing down here, so we can work through the other color. So if I chose to paint this one pink, then my other options, right, would be purple and green. And then my last one is I could choose to paint it green. And then that would give me the option of purple or pink. And so here, this gives me, in this case, right, if I look at adding all these up, so like this one can go here, or it can go here, or it can go here, or it can go there. When I add these up, to get the total number, it's going to be the same. So the total number of the same plus different. And so let's think about this equation for different. So now, like, how do I come up with this? Okay, so what is this, right? It's very similar to this, right? So this is the number of colors. So this part of the equation here would be the number of colors. And then we can see, like in this case, right, we actually have multiple. So if I had 3 colors, like it would multiply times that. And so I had 3 colors, so I subtract out 1. So it's actually colors times colors, the number of colors that we have minus 1, because we've already counted here. And so when I look in at this now, is that for my equation here, so same would have equaled 3. So I have 3. And here I start out with 3. So I say 3 times colors minus that, which gives me 2. So this gives me 6. And then I add these two together, right? And my final result here is 9. And another way to look at that is, why don't we just walk through, right? So I have 1, 2, 3. So I have 2, 3 options here. And then over here, I have 6, right? So I have 1, 2, 3, 4, 5, 6. So I have 6 plus 3, and then that gives me the total of 9. So this is really like one way to think about it, and we could have done a tree diagram, but it kind of makes sense here, right? Is like, think about it and think about like when I'm actually there painting and I'm coloring, it's like, then how do I come up with this equation? And you know, how do I work backwards from that equation when someone says, hey, I want you to be able to solve how when you can only paint 2 in a row, like how do you do that? So the next thing that we're going to do is so we have the equation. So for 1, it's paint the number of colors. And then for 2, it's the same, the number, which is the number of colors, and then plus the difference, which is colors times colors minus 1. And that's how we get this. So we'll next look at is like when we go, how do we then take this equation and continue to apply it for both 3, 4, and continuing on. All right, now what we're going to do is we're going to look at when we go to either a third, a fourth, or beyond pickets, how do we come up with that equation and what does that look like? At a high level, it is still the same plus different. So we look at which ones are the same, and then we calculate which is different. So in the first example that I have here, we're going to come up with like, how do we determine the same? And then work back from that to what does it look like in the past so that when you're looking at it, you can also derive it. So here, one thing to think about is I start here, my very first picket. And then to be able to create the second picket that's different, like purple goes to green, purple goes to pink, green goes to purple, pink goes to green and purple. So now our second picket, looking back, is different from our first picket. How do we determine how do we get our same then? So when we're coming back here, and we think about we have picket 1 and picket 2, if they are the same, then we're forced to have the third picket be different. Now, if we're looking at if picket 2 and picket 3 are the same, what has to happen in the past? In the past, picket 1 needs to be different for us. So doing that, if picket 1 is different than 2, then we can go ahead and say that our same is actually our past difference. And a way to think about that is, if I go same, same, then in the past, for my first picket, it has to be different. And if I go same, same, then in the past, my picket has to be different again. So our next one for picket 3, 4, and beyond, our same is simply what our past difference is. Now, one thing that's really interesting to look at is you'll be like, oh, I have green here and I have green here. How does that work? Well, you're looking at the permutations going backwards. So I can have 2 greens as long as they have a different starting first picket. And so here I have green, green with purple, and here I have green, green with pink, which is another different way to paint the fence. So that is how our next row for calculating the same is simply just saying same, just like what we did for picket 2. Same is it ends up being our previous different. So that's the basics of how you calculate your same going forward for 3 and 4. Now that we've walked through the same, we want to calculate the different when we're going from 3 plus. So there's really 2 pieces to this. We have, draw a line right here. What we want to do for different is there's 2 buckets. There are the ones that were generated when we had the same in the past. So if I had purple, purple, I could have pink and green. Or if I had pink and pink, I could have green and purple from my second to my third one. So one way to look at this is between 2 and 3, we can look at our previous same times color minus 1. And so that's one bucket of it. And if we look back, we could say, okay, I have green here. So going back, what could I possibly have? So looking back, well, I could have, in this case, I have the same, so I could have purple, purple, or possibly here, I have green and I could have pink, pink. So looking from where I'm standing back, the first part of different is looking at the previous sames times color minus 1. Then we also have to consider that different can come from another different. So if I start here with purple, I could come from green and then back to purple. Another combination for purple would be purple, pink, and back to purple, and then purple, pink, and green, purple, green, and pink. So when I'm here and I'm looking at my difference, I am my previous different times color minus 1. So what I have for both same and different, then another way to look at this is it is my previous same times color minus 1. And this part of it is my previous different times color minus 1. Now I can simplify that a little bit, and I can simply say my previous same plus my previous difference, or different, times color minus 1. And so that would be my equation for different, and then when I put together this what I had before on the same, and I simply would return same plus different. And so these are all of my combinations that I have here. So that is how, when we go from 3 plus, we do our calculations. We break it down into the same bucket, and we break it down into the different bucket. And then for our different bucket again, is those differences can be generated from our previous same, or they can be generated from our previous different, where our same were generated from our previous different. So that's the basics of how you can derive an equation, really like looking at the picket that you have and then looking one back and looking one back from that. You can derive your equation so that if you are in an interview and you get something that's a little different than this, you could whiteboard it out and you could be, okay, let me see the logic. Let me see the logic on the board. And then from that, let me see if I can figure out the equation, right? So I know like this is times 2 in this case, but really then what is that? Well, that is just colors minus 1. So this can apply for as many colors as we have. All right, so in summary, let's go back through all the different ones. When we have one picket, our equation is simply the number of colors that we have. When we go to 2 pickets, it is equal to for the same, which would be the number of colors of pickets that we have, plus the different, which will be the number of colors we have, times, and to be able to get the difference, which would be color minus 1. And then when we shift to 3, 4, and beyond, that calculation, very similar to this, is still same plus different, but to calculate the same, it's the previous difference, right? So when we have to be able to do 2 pickets, our previous one has to be different. So that's how we calculate our next same. And then our different can be both of those, right? It can be our previous same and our previous difference. And we're able to make permutations or changes from each one of those. And then it is times color minus 1, because we can shift, right? Just like similar to here. And it's similar to here where it's colors minus 1. And so this is our equation for 4, 5, 6, and beyond. And so hopefully that was a helpful way of walking back to actually see how to derive this equation. And then from this, we can then put it into code, and we can walk through each one of these test cases and start with 1 and then 2 and 3 and apply the same equations that we did here. And hopefully you can now visualize it on how, if someone gave you something like this, that you could derive it from there. All right, let's go back and look at 276, paint the fence. So there's a fence with n posts. Each post can be painted with one of n of k colors. You have to paint all the posts such that no more than 2 adjacent fence posts have the same color, just like we had walked through. And so our goal now is to return the total number of ways that we can paint a fence. All right, so for the first one, let's look at, one thing I like to do is create test cases. All right, so one of our first test cases, we'll just start from the beginning, which is what happens when we have one picket, right? When we have one picket, what can we do? Okay, so in that case, again, it's equal to the number of colors that we have. One thing that I also like to do, just to make this definitely more readable, is switch this up to pickets, or picket, and then also colors. It reads a lot easier as we're going through this, to be able to walk through that. So then when we have one picket, we can have that many colors. So here's what we can do. So if picket, right, if picket is equal to 1, then in that case, we're going to go ahead and return colors. So let's do this, and then we'll come here and we'll change our test case, right? So in this case, we'll have one picket, and let's say that we have 3 colors. So now in this case, right, we would expect to have it return 3. Okay, so exactly that, right? So we had 1 picket, 3 colors, and we returned the number of colors. Another one that we can do, which we didn't talk about, is what happens if we have 0 pickets. So another thing to think about is edge cases. So in this case, we're just going to go ahead and return 0 or none. So we'll go ahead and return 0. So let's go ahead and try that one. So our test case, so we have 0 pickets, and we can have as many colors as we want. So in this case, if picket equals 0, then we'll go ahead and return 0. And then since I'm doing this, I can bump this to an else if. So go ahead and run this one. And there we go. Since we don't have any pickets, we don't have any colors. So those are our vary two. Again, just to be clear, for like all of these, we can just say the number of our colors for this bucket would be 3. So we have 3 different buckets of colors, and then each. All right, so let's think about our next test case, which would be 2 pickets. And again, just a reminder too, is this is equal to the same plus different, with same equal the number of colors, and different equaling our colors times colors minus 1. Let me put this in brackets. All right. So let's go ahead and code that. So then we'll come down here. And so what we need to do is we need to calculate what our same is and our colors. So same is going to equal the number of colors that we have. And then our different is going to equal our colors times colors minus 1. Now the next thing that we need to do is that we need to check, right? So for this one, we need to check that we have 2 pickets. So if picket equals 2, then what we're going to do is come right back to here, right? We're going to go ahead and return the same plus different. So we'll go ahead and return same plus different. And then let's go back. We already have that. Let's see if we have the test case. Okay, so let's go back to our next test case. So in this one, we're going to have 2 pickets, and we have 3 colors. And we'll go ahead and run that. All right. So, and if we think about it again, when we go back to what we're looking at before, remember we had our 3 for the same, and we had 6 for different, and then we add our 3 plus 6 together, and then we have 9. So now we've walked through to 2 pickets. So then we can go ahead and get our next test case, right? And our next one would be having 3 colors. What would we get for our pickets? And if we look at this again, remember, it's the same equation, at least at the high level. So it's same plus different. And let me break it down here just a little bit more. So our same ended up being our previous difference. So same equaled previous different. And our different equaled our previous same plus our previous difference or different. And all of that is times color minus 1. And so that's our equation that we're going to use going forward. So let's go ahead and walk through the code for the next one, and from that it would be 3, 4, 5. It doesn't matter. So we'll repeat the same steps. So actually, in a way, this is like 3 plus, right? So that's the equation for 3 plus picket. So next, what we want to do is we'll want to go ahead and loop through as many pickets as they have asked us to go ahead and paint. So we'll say for post a single one of the single pickets in range, and we've already calculated 0, 1, and 2. So we'll start our range at 3, comma, and then we're going to go ahead and just say so the range function again, we have to add 1 to it. So we'll say picket plus 1, and that will walk us through up into the last picket. And so now the next thing that we need to do is we simply need to start doing our calculations of what we said before. So at this point, right, same is equal to previous different. And then our previous, or our difference, is equal to our previous same plus our previous different. And then all of this is times colors minus 1. And then what we need to do is we need to prep for the next loop, right? And so to prep for the next loop, we simply redo this again, right? We just say, we recalculate what our next previous same is and our previous difference. And so we'll continue to do that. And then all we have to do after that, after we've dropped out of the loop, so if we have 3 in this case, we'll drop out of the loop. Now we simply return the same plus different. So we don't have to do that. Let's see, double check. So we have previous same, previous difference, and we walk through the end of the loop. We have same, previous different, different, previous same, previous different, times colors minus 1. And we once again capture the previous difference for as many iterations, and then we simply return adding the sum of those two. So let's go back, make sure that we have our next test case. So our next test case, right, going back up here. So this time we're going to have 3 pickets with 3 colors. We'll go ahead and run that. All right. And so now we have 24. So looking back at our previous diagram, right, we had 24 as a result, which is the combination of our previous same and previous difference times that. So then we can try out some other test cases too, right? So we can come back here and say, oh, hey, what would happen if we had, let's see, we can come back and think, what would we have here? So maybe we can try 4 just to make sure that it works. We can come back and check the test case that it initially came with. And so we can have 3 and 2. Go ahead and run that. And just to make sure, and it's 6. Then we'll go ahead and submit it. And we can see that it passed. So that's the steps of how to go through and convert what we had on the whiteboard to code, and walking through test cases for each one of those to validate that, and then finally to the submission. Thank you. And finally, I wanted to thank you for taking the time to watch. Hopefully it was helpful. If you liked it, I have a goal of getting to 1,000 subscribers, so please subscribe. I'm going to try to do more of these where I've struggled, and hopefully try to help walk through and maybe show a different perspective that'll make it easier for you. And then finally, like to thank my daughter for the great artwork that she created for me for this video. Thanks. Bye.